meaning dkl of p of x, q of x is not the same as dkl of q of x with p of x. So it's not the same. Okay, so anyway, so the small code that I will put on the website, like I said, suppose we have some, could be test scores. Let's say the data is mostly centered around 70, and let's say we have another data which is mostly centered around 50, right? So we feed in two sets of numbers to this formula. What you will see is the KL divergence may produce an answer, for example, 3.5. Okay. Now, as we keep shifting it, the mean and the variance closer and closer to this one, which you will see will start to reduce and may come out to be 0.31. Numbers are not 100% the same, but the distribution, as long as the mean and the variance is very, very similar, you can convince yourself that it produces a low answer at that particular point, right? Okay, so that's one concept that we will need for statistical machine learning. Second concept we will need is okay, so we also have a good idea of the Bayes theorem. Some of you have already had probability and statistics. So let me give you just a 1-minute explanation of it. So Bayes theorem goes like this: P A given B equal to P B given A, P of A over P of B. Okay, so there's a little bit of a terminology that you will see as you read a lot of the deep learning research papers and so on. So you will see terminology, for example, a concept called prior, a concept called posterior, a concept called likelihood. Oops, I missed one. Is that right? Okay. Okay, and a concept called evidence. Okay, so it's important to have a clear understanding of what these terms are. Okay, so in the Bayes theorem, basically this part is called the prior. Okay, this part over here is called the likelihood. This part over here is called the evidence. And this part over here is called the posterior. Okay, so to give you a very, very quick example of let's say we wanted to determine probability of cancer given some test for cancer that came out positive as an example. So C for cancer. Okay, so somebody did a drug test, a blood test or something, and let's say test came out positive, but how do we know does the person really have cancer or not, right? So according to Bayes' theorem, this will turn out to be probability of B given A, so probability of test positive, given somebody has cancer, times probability of cancer divided by probability of test positive. Okay, and we can plug in some numbers. Let's pretend 90% of people who have cancer, see, we already know they have cancer, their test comes out positive, okay? Because some cases, even if you have cancer, it will miss it, right? Okay, and let's pretend 1% of the population has cancer. Okay, and let's pretend all the tests that were done. Okay, remember many people do the test who don't even have a symptom of a cancer, but they go to the doctor prescribes tests. So let's pretend 2% of all tests turn out positive, regardless somebody has cancer or not. So anyway, this gives us, if you plug in the numbers, this gives us a lot better idea of the probability that if somebody had a test for positive test for cancer, do they have cancer or not, right? Okay, so this part is not so important. Like I said, as we go through the mathematical theory, we'll be discussing the evidence, the prior, the likelihood, and so on. So this is where people get totally intimidated and lose the sight of the target. So let's try to understand the prior. Okay, so first of all, prior, take a look over here, has no conditional probability. It's like a basic fact that is given to us. Think of it like a previous information. What's the previous information in this example? That 1% of the population has cancer, right? So that's prior, will never have any condition applied to it, okay? So then evidence basically, again, is without any condition. So this is just like, again, a general fact. This was a fact on the cancer because that's what we are trying to determine. This is a fact on the condition that we are trying to test on. Okay, so that's what we call the evidence. Okay, and likelihood. Okay, given you have cancer, what is the probability that the test will be positive? That's what we call likelihood. And then lastly, this is the posterior, so likelihood and posterior will always be conditional probabilities. Okay. So let me have you, so are we getting close to our time? Yeah, so 4 o'clock. Okay, let me just show you our next handout. If you can lightly go through it, see if it makes sense or not. And then next time, I'll go over the whole explanation of it. So let me very briefly put it on the website. Put it on the screen. So we'll be combining Bayes' theorem, the KL divergence, expectation. So one more concept let me cover also. In probability theory is the concept of expectation. Okay. So in plain English, expectation basically means expected average value. Okay, so the formula for this, so E of x basically is, E of x is x times the probability of x. Okay. Again, to give you a very simple example, let's say you roll a dice. Okay, what's the probability of getting 1?
1 6.
1 6, right? What's the probability of 2?
1 6.
Sorry, 1 6 also. And same way, all 6s? Also 1 6, right? So the question is, what is the average number that we can expect as we roll a dice? Okay, will it be 3? Will it be 2? Will it be 4? What's your guess? How did you know that?
We will add them sum and divide 6.
Yeah.
1 plus 2 plus 3.
So, yeah, the answer is correct, but I'm impressed you're able to give me the right answer right away. So that's why I was asking.
I remember it from my probability.
Oh, from your probability class, okay. So as you can see, this will be x is 1, probability is 1 over 6. X is 2, probability is 1 over 6, plus 6 times 1 over 6, right? Can I write it as 1 plus 2 plus 6 times 1 over 6? right? So this is a regular arithmetic series. Sum of the arithmetic series is the last number times the next number divided by 2 times 1 over 6. So this is 21 times 1 over 6. So you'll see it will come out to be 3.5. Okay. So anyway, as you go through the handout, which we'll cover in detail next time, and then I will show you how the code that we write corresponds to all the mathematical equations that we develop. Okay, so I also have put this loss function derivation. Okay, so anyway, you will see there are concepts of expectation over here, concepts of conditional probability. There's the Bayes theorem getting involved over here. Okay, so the idea again is some data x is given some distribution p of x, right? As we go through the encoder, it produces some distribution q z given x. Z is the output over here. So z given x. Okay, so what we want to do is we want to force this distribution now to follow p of z. And can you guess what should p of z be? So this will be our goal over here. This will be a normal distribution. So we want the output here to follow this distribution. Okay, and of course as we go through the decoder, we recover so this is the posterior, so that we recover the original, right? Okay, so the KL divergence will get involved between QZ of x and P of z because we want to force this to follow the normal distribution. So so try to go through this part, see as much as it makes sense. Okay, and I've tried to clarify as much as I can. And by the way, from this part, the star part, then the next part is towards the end because I ran out of space. So anyway, the final result, like I said, is called evidence lower bound. And evidence, remember I told you, is not a conditional probability, but why is it p of x? Why is it log p of x? So there are a few other concepts that I'll clarify. But once we put it all together, then you will see how beautiful this is, what kind of results it generates. And I myself is amazed at whoever came up with this. It took me a week to understand the math, but anyway, it's pretty neat in my opinion. So, okay.